Mosquito Attack. This is the plant show where we go around and get eaten by mosquitoes while we try to talk about plants. I'm here in my backyard in Knightdale, North Carolina, as well as my neighbor's yard over there, who is a great gardener and has lots of useful plants for what we're going to talk about today. So, as you probably know, way back in the beginning of Earth's history, all life evolved from in the oceans. And this includes plant life. So some of the earliest forms of plant life were called cheirophytes, or green algae. These were unicellular organisms that had flagellated gametes, and what that means is that their sperm and their eggs had little tails that allowed them to swim through the water, which was perfect for cheirophytes because they lived entirely in the oceans. They also had tissues that were really good at soaking up water, which is good for taking like the CO2 out of water and the other things they needed to grow, but it was not great outside of the water because it would dry up really fast in the heat and the sun and the air. So, with that in mind, if green algae is the ancestor of all the plants I see around me today, then how do we have so many plants here on land when they weren't really suited to living there? And so what we're going to talk about is some of the evolutionary adaptations of the future forms of plants that allow us to have all of these things here on land. The first adaptation, so this is the first forms of plant life that stopped being green algae and came out of the oceans, were called bryophytes. And what this is things like moss and liverwort. And here we have some moss right here. You can kind of see it in there. So bryophytes are, like mosses, are very short, and you find them growing in very moist areas. And the reason you find them growing in moist areas is because they still need some moisture, even though they don't have to be completely submerged in the water the way that their ancestors did. So these bryophytes developed what's called a waxy cuticle. And what waxy cuticles do is it's sort of this waxy substance on the outside of the tissues of the plant that helps them retain moisture inside them so they don't dry out and desiccate when they're outside of the water. However, they do still need moisture because their sperm, their gametes, their sperm and eggs, are still flagellated and still need to swim through moisture in order to reproduce and have more mosses. They also are really low to the ground. Mosses don't have stems or roots the way we see with other plants, and this is because they still are so close to that original ancestor, the cheirophytes. So you'll find them in really moist areas, both so they can reproduce and so that they can get their water and their CO2 and their minerals and that sort of thing, but that waxy cuticle means they don't have to be completely submerged. So after the bryophytes came the pteridophytes, and the pteridophytes are things like ferns. So ferns, like bryophytes, have that waxy cuticle. That means that they're able to retain their moisture and they don't just dry up as soon as they go out on land. But they also developed something that bryophytes didn't have, which is vascular tissue. And what vascular tissue is, it is like sort of this porous, firmer tissue that allows them to grow taller and have stems, so that's why we see ferns higher up than moss. They also still reproduce via spore. So you'll still find ferns in damp places, like in temperate or tropical rainforests, like in Pacific Northwest, or sometimes here in North Carolina. So these over here are called ostrich ferns. I'm going to see if I can get close enough for you to see them. Here you are. Like that. So I don't know if any of these will have the spores on the back, but sometimes you can see these little yellow dots on the back of ferns, which is where their spores are. So pteridophytes still have that waxy cuticle that allows them to live out of the water, but they have this new vascular tissue which allows them to grow taller and have stems. However, they still need moisture for their little swimmer gametes in order to reach each other. So after the pteridophytes, we move on from those little swimming gametes into the gymnosperms. And so gymnosperms, what that means is naked seeds. So these are our trees like conifers or cone trees like pines. And so what these trees do is they have, instead of just having their gametes out floating through the water, these are protected in seeds, and their gametes are things like pollen. That's one of the reasons North Carolina has like those pollen apocalypses, where pollen just gets all over the place, it covers your car and soaks through the water on the ground, is that pine trees will release all of their pollen at once through the wind for them to find other pine trees, fertilize them, and then form those little seeds and like pine cones and things like that. From there, pine cones will drop to the ground, where they'll get eaten by like birds or mammals, the mammals and the birds will travel and then poop, and they'll poop out those seeds so that a new pine tree can grow somewhere else. So this is a baby pine tree called a loblolly pine. And you can see here where it's kind of hard at the center. That's from a chemical called lignin, which comes from that vascular tissue, which forms what we know as wood. So when we have pine trees grow up really big and tall and have that hard bark, that's because of that chemical lignin. And same way, these have waxy cuticles over their little pines so that they retain their moisture. These also have stamen, which are these little opening and closing, almost like mouthpieces on the leaves, which allow them to take in CO2 from the air rather than from the water. So after the gymnosperms, oh, here's an example of one of those pine cones, where if you open it up in here, I don't know if you see that, yeah, in there, that's where you'll find those naked seeds. So these will drop to the ground, animals will eat them, travel with them in their bellies, and then the feces will grow new pine trees. After the gymnosperms came the angiosperms, and this is the major form of plant life that we can see all over, everywhere. Most of the trees you see back there, most of the flowers over here, and actually I'm going to show you these flowers right here because they're really dramatic and pretty. So angiosperms have a lot of the same adaptations as their predecessors. They have that waxy cuticle that allows them to retain moisture. They have the vascular tissue, which allows them to grow tall and soak up water from the ground. They have their gametes protected in pollen, or separated by pollen and seeds rather than in spore form. But angiosperms are special because they have flowers and fruits. So what these flowers and fruits are for is they're usually bright colors, or they smell good or they taste good in order to attract pollinators or animals to come and eat them. So being this bright and pretty flower, they'll have bees come over, collect the pollen, and spread it out to other flowers so that they can have more flower babies. Angiosperms, like I said, some of the most common that we see today. Every fruit or vegetable you eat, all the flowers, things like that, those are all angiosperms. Oh man, okay. So, what have we gone over today? We talked about chirophytes. This is the green algae, it's the ancestor of all plants we see today. It grew in the oceans way back at the beginning of Earth, or the beginning of life on Earth. Unicellular, had their gametes as little swimmers that needed water in order to move around and have more babies, and they also, their tissues were really porous in order to collect CO2 out of the water and that sort of thing. Ooh. So they cannot survive on land. Bryophytes got that waxy cuticle that allowed them to retain water and stay on land. They grew in moist areas so that their gametes could still swim and find each other. And yeah, that moist areas allow them to reproduce, also allows them to soak up water themselves since they don't have roots, and that waxy cuticle allows them to retain that moisture. Ferns, pteridophytes, came after the bryophytes. They had the waxy cuticle, also had the vascular tissue that allowed them to have like a stem and grow taller, so they could retain that water and get the water from the ground rather than just being in moist places, but they still reproduce via spores, which means that their gametes still needed to swim, which is why you find ferns in places with a lot of moisture, like rainforests. After that we have the gymnosperms, like the loblolly pine, who have naked seeds, and those naked seeds are eaten by animals after they have the pollen that goes to the wind. The animals will eat the seeds, poop them out, so pines will grow somewhere else, those gymnosperms will grow somewhere else. They also have that vascular tissue that hardens with that chemical called lignin into wood. Lastly, we have angiosperms that have all the same adaptations as the other ones. They have the waxy cuticle, they have the vascular tissue, they have the pollen and seeds rather than spores, but they also have flowers and fruits, which attract insects and pollinators to come move their pollen around, or encourages animals to come eat their fruit with the seeds and then poop them out at a different destination, spreading out their babies. Okay, that has been Mosquito Attack. We have been thoroughly attacked. And we are done. Thank you so much for watching, and we'll see you next time. Bye!